સ્ટુડન્ટ આવતા જો આપણે થોડોક ટાઈમ લાગી જશે એમ.
હા હા, નો નો પ્રોબ્લેમ.
હા, આપણે લાઈવ થઈ ગયા છીએ સર.
ઓકે.
હા.
কিন্তু પ્રોસેસિંગ એવું બતાવે છે અહીંયા મને.
અચ્છા, હા. એકવાર નેટ ચેક કરી લેજો જો કદાચ પોસિબલ હોય તો.
નેટ તો
શેર
મારું
કરવાનું
જે
છે. પ્લસનો આઇકોન હશે ને સર ત્યાંથી હા,
હા
આવી
હા
ગયું સર. આવી
આવી
ગયું.
ગયું ને? હા હા.
હા,
ઓકે.
હા આવી
હા
ગયું સર. બરાબર છે ને?
હા, ડન.
ડન સર? સર
હા
યુ કેન
હા.
સ્ટાર્ટ ધ સેશન સર.
ઓકે. આમાં ઓકે, સ્લાઇડ ચેન્જ. ઓકે,
હા,
ડન.
થઈ જશે સર.
ઓકે. હા તો સર, હાલો.
યસ સર. હા,
હા,
યસ સર.
સ્ટુડન્ટ સર ઓટોમેટિક જોઈન થઈ જશે કે?
થઈ ગયા છે સર. સ્ટુડન્ટ ઓલરેડી જોઈન થઈ ગયા છે સર.
ઓકે, ડન
હા.
સર. Good morning, students. Myself, Dr. Sandeep Chavatia, Associate Professor, Department of Bioscience, Saurashtra University. Students, today we are going to discuss about the hypothesis formulation and testing of hypothesis. When we're discussing about the hypothesis formulation and testing, in that specifically when PhD students, they are mainly focused onto the different tests, which is known as a Z test, T test, as well as F test in detail. Okay, we're discussing about each of these tests. So first we start with the what is a hypothesis. So in that, okay, when we're discussing about hypothesis, so you are now a PhD student or research student. So tentatively in your mind, some research problems are there. Okay, so we test that research problem in with the help of a statistical method, and after that we analyze whatever our contents are there, data are there, and according to that we come with the specific conclusion. So this is actually the aim behind the formation of hypothesis. So one by one we discussing about each of point. So here, hypothesis, which is a tentative or we can say testable statement or assumption, which is made to explain a phenomena or relationship between the different variable. For example, when we discussing about the different variable, so we all are the biological students. So in that, our perception is that, for example, any field is there. In that, we give the irrigation or we also add the fertilizer. So how this fertilizer or irrigation they help to produce that yield, or it can improve the yield or not. So these are the tentative statements, and we test this tentative statement in relation with the whatever our phenomena which is there, or whatever the relation between the variables are there. Next, when we're discussing about okay, whatever the with us existing knowledge which is there, or whatever our observations are there, whatever our theories are there, they serve as a guiding framework for our scientific investigation. Like I give the example of this fertilizer, irrigation, as well as the crop improvement. So in that we have certain knowledge. If we give the fertilizer to the crop, then definitely crop yield which is improved. So likewise, we have some basic knowledge. We observe these phenomena. Okay, yes, if we irrigate one time, two time, or three time, and then it also help us to improve the production of crop. Then whatever our theories are there, we correlate all these things for our hypothesis. Next, we're discussing about hypothesis, which is a predict the outcome of studies and can be accept or reject after synthesis or whatever our data which is collected and when we do the analysis. Next, a hypothesis, which is a statement, what we are looking for, and it is a proportion which can be put into the test or determine its validity. Whenever we're discussing about this hypothesis is what? Okay, it is a actually bridge between the what are the gap which is there for the theoretical data as well as whatever the experimental data which is there. Between these two, what are the gap which is done with the help of the hypothesis. Next, when we're discussing about, for example, students who receive the counseling, okay, they definitely get better result. When we compare with the students, they are not receiving the any counseling. Maybe you also go through this all of the things that okay, if okay whatever the for example we take the example of students they study into the 10th standard when they are give the counseling or we can say the tuition, okay, then they get the better result when we compare with the whatever the students they not receive the specific counseling. When we're discussing about the which are the criteria or characters should be there when we form the hypothesis. So first and basic characters to design the hypothesis is that okay, it should be stated in the simple manner or whatever we state, okay, in that whatever we use the language, okay, which is not that much ambitious or so that it can mean very easily to understand. For example, in many researchers are there, they have the ambitious nature. Okay, I achieve this much, I achieve that much. So, but when we design the hypothesis, so in that we think that okay, in certain period of time we are can reach there or not. For example, many students, okay, we work into the wildlife. Okay, for example, we work into the lion genome. We work into the whatever the wild animals genomes are there. So for that, we require to collect the blood or other samples we requirement. So in that, the ambitious, okay, nature of the hypothesis which is not required whenever we discussing about the formation of hypothesis. Next things which is capable of testing of that hypothesis. Okay, we are in the position of that. Okay, now we can do this certain experiment or observation or statistical analysis, and after that we can come to the specific conclusion. Many times students what they do, they design certain experiment in the certain way that okay, it is not completed within a period of time. So this is also one of the simple things when we think about the hypothesis. Another important things which is the observation. Certain observations. Okay, for example, the behavior of a lion into the wild. Okay, for that certain obstacles are there to us. Okay, we can not able to observe the specifically activities of lion whatever the cubs are there. So likewise, the observation, okay, for the good hypothesis, it also be clear, and what are the statistical analysis which is also required. Next, when we discussing about the relationship between what are the variables are we design. For example, when we discussing about the different variable, we take the example of okay, we take the medicinal plant, and the medicinal plant maybe it help to reduce the diabetes type 1 or type 2. So likewise, specifically, whatever the phytochemical constitute with the medicinal plant which is there, it should be affect the what are the metabolism of glucose which is there. So here the simple relationship which is required between the different variables. For example, we take the okay any ornamental plant and we suggest that okay, this plant can be affect to reduce the diabetes. So this is not possible. So specifically, we take the medicinal plant and we conclude with that okay, some of the secondary metabolites which is there with the medicinal plant, it can help to reduce the diabetes. So likewise, specific relationship which is required between the different variables. Next, when we're discussing about the limited scope and must be specific. So in that, students, we think, okay, whatever we design the hypothesis, it is should be in the narrow, or they are with the focus of any specific objectives you represent, okay, during the DRC, whatever the, or you design the different objectives. So here, whatever we design the hypothesis, it is specific to that specific objectives, and within the available time, it should be completed. For the completion of that, different resources which is available or not, and for the completion of that, different methods are there or not. So whatever these things are there, for example, available of time, resource and methodology, they should be very specific when we design the hypothesis. Next, when we're discussing about the stated as far as possible in most of the simple terms, so that the sum which is easily to understand by all the concerned person. Okay, whatever we design the hypothesis, it should be in such a way that it is easily understood by any person. Okay, if we have the different lab mates are there, then all the lab mates can be easily understood, okay, whatever our hypothesis which is there. So it should be simplified, but it not mean that, okay, whatever we design the hypothesis which is not significant in the specific way. Any hypothesis which is there we design, they have the significant contribution into the research. Next, we are also consider some of the fact, okay, or we also know certain fact for the designing of the hypothesis. Next, responsive to testing with it, which is a responsible time. One can spend a lifetime collection of the data, which is not possible. So, students, we design the hypothesis in the such a way that, okay, we complete whatever our objectives are there within a certain period of time. For example, some of the botany students, okay, they work onto the certain plant. So it is not that, okay, these plant, okay, they are flowering twice in the year, or we can say after 2 years, one plant they give the flower, and whatever the students are there, they are working on that flowering plant. So it is not possible or not desirable to the student. So specifically, whenever we design the hypothesis or any object, we keep in the mind that whatever we design, it should be completed in within a specific time, and for that collection of data, okay, we get which is very easily. Next, whatever we claim, okay, of the data, it should have the empirical reference. So with the help of some of the reference, we should claim the specific data. So for that also, student, you keep in the mind that whatever you design the hypothesis, which is a very simple, as well as whatever the objectives are there, according to that your hypothesis should be met, and according to that you design the methodology, you have specific resources, and in spite of that, a specific time bound data collection which is required. So these are the basic characters of the hypothesis. Okay. Next, we're discussing about the formulation of hypothesis. How we design the hypothesis, or how we formulate the hypothesis. So for that, formulating a hypothesis, which is a systematic process that involves several key steps to ensure that the hypothesis, which is very clear, testable, as well as relevant to the research questions. In that, the first and basic steps, student, for us, which is identify the research problem. Okay. For example, we take the example of Junagadh. Okay. In that, now, what is a research problem for us? For example, what are the wild area which is there, or wildlife which is with us? Okay, at the national park or the sanctuary, they are affected by the industry or not, or any, or whatever the modernization or the civilization, it can affect that or not, or maybe day by day what are the pollution which is increased, it can affect that wildlife environment or not. So likewise, first focus of us is to identify the research problem, and according to that what we do, okay, we go for the review or literature which is exist with us. For example, in the Junagadh in the year 2020, the five industries are there surrounding to the Gir National Sanctuary or National Park. Now, in the year 2025, the whatever the industries are there, they may be the 5050. So we compare, okay, at the time what is the condition of the national park or sanctuary, what is the condition of flora as well as fauna. If this review which is exist with us or literature which is exist with us, then based on that we hypothesize the thesis or our research problem based on that literature survey. After that we define the specific variable. For example, when we discussing about the any environmental pollution like study, then we have the different specific variable with us. For example, the concentration of the air pollution, water pollution, or noise pollution. Okay, so these are the variable. In the for give the example of for example water pollution. So in that the variables are the level of COD level, BOD level. So we define that specific variables in our study, and according to that we formulate the hypothesis. Next, very important and basic things which is a formulation of hypothesis. After that, we ensure that okay, these hypothesis which is a testable or not. Then we consider the scope as well as the specificity of this hypothesis. Okay, whatever we are going to do the study, it is helpful or it is beneficial to the society or not, or which kind of other scopes are there, and based on that we conclude something and which is ultimately helpful to the society or flora or fauna which is present surrounding to us. Then based on our whatever findings are there, we refine the hypothesis also, and later on we state the specific hypothesis. Okay, this is my hypothesis. Okay, this industry which is established surrounding the Junagadh, it can cause the flora and fauna of the Junagadh or wildlife sanctuary or whatever the national park which is there. So likewise, we construct our hypothesis. So formulation of hypothesis, in that whatever these steps are there, they play an important role. One by one, in detail, we discussing about each and every point. So first, identification of research problem, which is a main and important task students for us. So hypothesis formulation begins with the clearly define the research problem or what are the questions are there. This involves understanding the broader topic of our interest, as well as we can also narrowing it down to the specific issue or question that you want to explore. So students here, whatever you do the RDC presentation, in that you keeping these specific things in your mind, and then you design the hypothesis. Okay, whatever the problems are there surrounding to you, which are the questions which is arise, and which kind of topic we select, and how we deal with this. Okay, okay, we have the any specific questions or not. Nowadays you heard about in the newspaper, or you read in the newspaper that okay, what are the human wildlife conflicts which is increased. Okay, so this is the identification of research problem. Okay, okay, nowadays the human as well as the wild animal conflict which is there. So this is the problem for your or your concern. So based on that you design such a hypothesis. Okay, in that, what are the variable? How this can happen? Why the wild animals which is come into the human territory, or if the humans they are interfere with the wild animal. So this is the research problem for us. So based on that, okay, we going for the review literature. If this review literature which is exist with us or not. Maybe previously some of the students, some of the researchers, they do this kind of work or not. Maybe they do that work, okay, decade ago, before 10 years, they do this kind of research. So now, which kind of situations are changed or not? So after the identification of research problem, a thorough review of the existing literature which is required student for you to constructive step designing. This help you to understand what is already known about the subject, identifying the gap in the current knowledge, and providing the theoretical basis for your hypothesis. So, second important step, students, for you, that review literature. Whatever the existing review with you, you thoroughly go through all this review literature, and according to that, you define your problem, hypothesis, objectives, or we can say we define the specific variable according to that. So this is a second important point, students. Okay, a review literature study. Third, which is define the variables. In this step, we identify the key variable involved in your research. Determine which variables are independent, those you will manipulate or consider as the cause, and which are dependent, those you will measure or consider as a effect. So here the two kinds of variables are there. One which is the independent variables are there, and second which is the dependent variables are there. For example, we can say the construction of the human population or the human house into the core region of the sanctuary, or we can say the whatever the national parks are there. So which is if we construct something there, then and then only wild animal they are attacked to the human population. So which is dependent to each other. Okay. So some of the variables are also independent. So likewise, you design or define the different variables which specifically help to study your research problem. So this is a third specific a point in the hypothesis design. When we're discussing about the fourth, which is a formulation of the hypothesis, based on the what are the 3 points we discussing. First, which is the identification of research problem. Second, which is a review existing into the whatever the literatures are there with us, and according to we define the different variable. With the keeping of these three in our mind, we formulate the hypothesis uh, in context with all of these three. So in that, what we do, okay, we develop a clear as well as a consecutive statement which is a predictable, and the relation between the independent as well as the dependent variables. This statement should be specific as well as testable, meaning it can also support or refuse through the whatever empirical evidence are there. May it happen that whatever we design the hypothesis, it not be true, okay, for us or to the certain level. So it should be empirical. To review this, empirical evidence are required with us. So step number 4, students, which is a formulation of the hypothesis. Okay. Basically, you maybe read or heard about two kinds of hypotheses are there. One which is known as a null hypothesis, which is simply known as H0. So formulate the null hypothesis which asserts that there is no effect or relationship between the variables. Second, which is an alternative hypothesis, which is known as H1 or HA, In that, formulate the alternative hypothesis which suggests that there is an effect or relationship between the variables. So once again, in that we take the example of whatever the crop improvement with the organic fertilizer or inorganic fertilizer, if we keep in this mind. So first, whenever we design the null hypothesis, that we deny that okay, whatever the fertilizer is there, they are responsible for the improvement of the crop. So simultaneously, we design the alternative hypothesis in the such a way that okay, it suggests okay, whatever the fertilizer which is there, they can help to improve the our yield production. So likewise, we design the null hypothesis as well as alternative hypothesis. Now number five, which is we ensure the testability. Okay, whatever we collect the things, it can be testable with the statistical method or not. So make sure that the hypothesis which is a testable. This means that okay, it should be possible to gather the data that either supports or refuse the hypothesis through the observation, experiments, or other research methods. Students, I give the simple example of this. Okay, we ensure the testability. If we design the hypothesis that okay, onto the moon, okay, the lion which is there, if we design such kind of hypothesis, so which is not possible, we cannot get any observation, we are not able to design any experiment, or we can say that okay, on the Mars, okay, a human population which is there, or it human can be survive onto the Mars. So such kind of hypothesis, okay, which is not able to test by us, okay. So we design the hypothesis in a such a way that okay, we ensure their testability. Okay, now we can able to collect the observation data, or we design such experiment, and based on that we can able to test that specific hypothesis. And number six, consider the scope as well as specificity. After ensuring the testability of the hypothesis, you should make sure that hypothesis is neither too broad or nor narrow. Okay, whatever we design the hypothesis, it helpful or useful. Okay, or the broad aspects are not there, and it is not too narrow. For example, fertilizer, we can say that in that okay, if we give the NPK, okay, to the specific crop, for example rice, then we sure that can the production which is improved. So likewise, whatever we design the hypothesis, in that scope as well as specificity which is required. Number seven, when you're discussing about the number seven, which is a refine the hypothesis. After viewing, okay, whatever our observations, experiment, and research methodology, if we get some negative result, okay, on the basis of our observation, then we have the scope for refine the hypothesis. Okay, now in this direction we are not going. Based on our findings, we define our hypothesis in a such a way that okay, we get something on the another direction. So students, whenever you define any hypothesis, in that you keep in the mind that okay, refine the hypothesis, which is also the Hello, 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 answer. Hello, hello.
Yes.
Sir, visible છે ને audible છે?
હા સર લાઈવ તો બોલો
ઓકે ઓકે, કાંઈ વાંધો નહીં સર. So we are discussing about the state of the hypothesis. So this is a step which is required to express the hypothesis in such a way that we constructively formulate some statement regarding our research work. So it should include your research proposal or study designing, providing the what are the foundation of the research. So this is the last, which is a state the hypothesis uh, based on whatever we discussing about the point. Ultimately, we state number 8, which is the last one. Okay. Whenever we're discussing about the testing or hypothesis, we keep in the mind this specific table. In that, what the table express. Okay. Later on, once again, we're discussing about this. But at present, we simply discuss this. Okay, if okay, our hypothesis which is true, okay, then we accept. So, which is a correct decision for us. If our hypothesis which is true, and then we reject this hypothesis, here you see that we reject this hypothesis, so which is a type 1 error for us, which is also known as the alpha error. If our hypothesis, okay, which is false, and then also we accept our null hypothesis, then which is a type 2 error, which is known as a beta error. And if our null hypothesis which is false and we reject the null hypothesis, so which is also the correct decision. So likewise, whatever we discussing about the decision part, two types of decisions are there. One which is a null hypothesis which is true, then we accept the null hypothesis. And second, if the null hypothesis which is false, then we reject the null hypothesis. So which is also the correct decision for us. In that, are two kinds of error which is made by us by chance, which is known as a type 1 error as well as type 2 error. In detail, we discussing about these two error later on. Okay, so now we discussing about the different type of hypothesis. So already we discussing about the one which is null hypothesis. Second, we discussing about the alternative hypothesis. Many other hypotheses are there. With the help of example, we discuss these types of hypotheses. So in the research methodology, hypotheses are classified based on their formulation, relationship between the variables as well as statistical testing. The main types are as follow we discussing. First, which is a null hypothesis. So in the null hypothesis, we state that the no relation, difference or effect between the variables. It is the hypothesis tested for possible rejection in the statistical analysis. So which is known as a null hypothesis, and it is denoted as H0. If a population mean which is equal to whatever our hypothetic means are there, the null hypothesis can written as H0 is to mu. Mu here, which is a population mean. You know that. If you don't know that, then I told you that okay, whenever you see the mu represent the population mean. Okay, you heard about the mean, mode, and median. So in that, what are the mean which is there? Simply you see the mean in the form of x bar. But when we're discussing about the population mean, so it is represented in the form of mu. So here the null hypothesis, which is a mu is equal to mu 0. For example, there is no significant difference in the growth rate between the treated as well as untreated plant. Simply, I give the example of that. okay, if in one plot I give the fertilizer or treatment to the plant, and in another plot I not give any kind of fertilizer or treatment to the plant. Okay, so my null hypothesis is that okay, what are the population mean? Mu is there is equal to mu zero. It means no significant difference into the growth rate between the treated as well as untreated plant. So this is the number one, which is known as a null hypothesis. Simply we deny the relationship between the any kinds of treatment in sense of it is effective or not. So this is known as a null hypothesis. So this is a number one, which is a null hypothesis. Number two, which is an alternative hypothesis. So alternative hypothesis, which is a negation of the null hypothesis, which is denoted as a H1 or HA, state that relation, difference, or effect does not exist. In the null hypothesis, what we give or we formulate like this: okay, H0 is to mu equal to mu 0, means population mean equal to whatever we get the our mean. But when we're discussing about the alternative hypothesis, it should be written as H1 or HA is to mu not equal to mu 0, means whatever our population mean is there, it is not equal to our observed mean. So this is number one statement. Number two, H1 is to mu, which is a greater than mu 0. Or number three, H1 is to mu, which is less than the whatever the mu 0 which is there. So it is accepted when the null hypothesis which is rejected. When we reject the null hypothesis, then we accept the our alternative hypothesis. For example, there is a significant difference in the growth rate between the treated as well as untreated plant. Okay, we basically know that okay, if we give some treatment to the plant, then maybe it happens that it gives the significant growth rate into the plant. So this is about the our alternative hypothesis. Always we design the our null hypothesis in the form of that there is no significant difference between the populated mean or specifically whatever our sample means are there. Here once again student, I told you mu which is a population mean and mu 0 which is our sample mean. And number three, okay, which is known as a simple hypothesis. So predicts a relationship between the one independent variable as well as another dependent variable, which is known as a simple hypothesis. For example, increase the temperature definitely increase the enzyme activity. Okay, certain temperature. For example, enzymes they are activated at the 37-degree temperature. Okay, then if we increase the temperature to the 4040 degree centigrade, then here we simply state that simple hypothesis is that okay, increase the temperature, increase the enzyme activity. So here only one variable which is there, which is a independent variable, and they can be depend onto the dependent variable. So it is known as a simple hypothesis. When we're discussing about the complex hypothesis, okay, in that one or more independent variables are there and dependent variables are also there. For example, okay, dependent variable means enzyme activity, and independent variables maybe we take the one or two variables such as the temperature, pH, maybe the carbon source, maybe the nitrogen source. They definitely influence the enzyme activity. So when we design such kind of hypothesis, then it is known as a complex hypothesis. Maybe students you are aware, or maybe you get the things what is a simple hypothesis or what is a complex hypothesis. Maybe you understood about the independent variables as well as dependent variable. Independent variables means we can able to increase or decrease that specific range. For example, temperature. If I have the temperature of 20 degrees centigrade, then 25 degrees centigrade, then 30 degrees centigrade, 35, 37, 40, 40. So likewise, whatever these independent variables are there, and dependent, based on the temperature increase, enzyme activity, which is a dependent. Okay. તો જે ટેમ્પરેચર જે છે ઇન્ક્રીઝ અથવા તો ડિક્રીઝ થાય છે, બરાબર, એની ઉપર એન્ઝાઇમ એક્ટિવિટી ડિપેન્ડ કરે છે, એવું સિમ્પલ હાઇપોથિસિસમાં આપણે સમજ્યા. But when you're discussing about the complex, in the complex what happen, કે whatever the variables are there, okay, they increase. જો તમે ભણેલા હોય, બરાબર, એન્ઝાઇમ એક્ટિવિટી વિશે, તો તમને ખબર છે કે જે એન્ઝાઇમ પ્રોડક્શન છે એ મીડિયા ઉપર, બરાબર, ડિપેન્ડ હોય છે કે મીડિયાનું કમ્પોઝિશન શું છે, બરાબર. પછી જે પણ એન્ઝાઇમ છે એ બાયોમોલેક્યુલ્સ છે, તો એને સ્પેસિફિક ટેમ્પરેચરની રિક્વાયરમેન્ટ છે એના ગ્રોથ માટે, સ્પેસિફિક પીએચની રિક્વાયરમેન્ટ છે એના ગ્રોથ માટે, સ્પેસિફિક એને કાર્બન સોર્સની રિક્વાયરમેન્ટ છે એઝ અ ન્યુટ્રિયન્ટ, એને સ્પેસિફિકલી whatever the on different temperature, pH, media which is required for their specific activity or stabilization. So which is a complex hypothesis. When we're discussing about the directional hypothesis, number 5, so here specific the direction to the relationship between the variables they specify. For example, application of fertilizer increase the crop yield. Directly we state that, okay, when we apply the fertilizer, it should increase the crop yield. When we're discussing about the non-directional hypothesis, એમાં કોઈ specific direction આપતા નથી. તો એનું એક્ઝામ્પલ શું છે, તો કે ફર્ટિલાઇઝર એપ્લિકેશન અફેક્ટ ધ ક્રોપ yield. તો જો બંનેના સ્ટેટમેન્ટ શું ડિફાઇન કરે છે, એમાં સ્પેસિફિકલી આપણે કહીએ છીએ કે એપ્લિકેશન ઓફ ધ ફર્ટિલાઇઝર ડેફિનેટલી ઇન્ક્રીઝ ધ ક્રોપ yield. બટ here what we give the statement that the fertilizer application affect the crop yield. So likewise, okay, yeah, non directional માં શું કહે છે, આપણે અફેક્ટ કરે છે, શું કરે છે ભાઈ, ક્રોપના yield ને. એમાં સ્પેસિફિકલી આપણે કરતા નથી કે ઇન્ક્રીઝ જ થાય છે. મે ઇટ હેપન ધેટ કે ફર્ટિલાઇઝરમાં કોઈ એવો કમ્પોનન્ટ છે એ ક્રોપને ડિક્રીઝ પણ કરી શકે yield ને. સો લાઇકવાઇઝ અહીંયા કેવો વર્ડ વાપર્યો છે કે fertilizer application affect the crop yield, whereas when we discussing about the directional hypothesis, in that we use the word like, so what are the applications of the fertilizer, they definitely increase the crop yield. So our difference between the number 5 as well as number 6. When we're discussing about the number 7, which is a research or working hypothesis, so here what are the provisional statement formulated for the empirical testing during the course of research, okay, often used into the whatever the exploring the study. For example, okay, marine fish mussels, they contain the bioactive compound with anti-cancer property. So many students, okay, they are working in the marine science, okay, if they design this research work, okay, so here what are the statements which is there, or example which is there, it indicate what, okay, whatever the students they work onto the marine fish mucus, okay, they have the bioactive components, they affect the cancer. So likewise they design the research point of view, okay, the hypothesis or working hypothesis. So it is known as a research or working hypothesis. Number 8, which is a statistical hypothesis, in that the hypothesis which is expressed in the statistical term, okay, suitable for the qualitative analysis, include null or alternative hypothesis. So which is known as a statistical hypothesis. Anyone they ask about that, okay, what do you mean by statistical hypothesis? So whatever we design the hypothesis in the term of statistics, okay, which is known as a statistical hypothesis. For example, whatever we design the null hypothesis as well as alternative hypothesis, which is a one type of statistical hypothesis. Number 9, which is a logical hypothesis. So based on the logical reasoning, okay, rather the immediate empirical testing which is possible or not. So this is a logical hypothesis common into the theoretical or philosophical study, okay, based on the theoretical study, okay, or whatever the students they do the work into the mathematics, okay. So they design the mathematical formula or theoretical work, or maybe some students they are working into the philosophical field. So based on the questionnaire only, they form the logic, okay, and according to they design this hypothesis, so which is known as a logical hypothesis. So which is a number 9, which is a logical hypothesis. When we discussing about the number 10, which is a empirical hypothesis, so it is formulated on the basis of observations or the experimental data. Okay, if I have the experimental data with us, and based on that we design the hypothesis, which is known as a empirical hypothesis. For example, બરાબર, મારી પાસે એક પર્ટિક્યુલર ડેટા છે, બરાબર. એમએસસી નું રિઝલ્ટ છે મારી પાસે સેમેસ્ટર 1 નું બધા સ્ટુડન્ટ્સનું. ઓકે, તો એના બેઝ ઉપરથી મને ખબર પડે છે કે ભાઈ ક્લાસની અંદર 50% સ્ટુડન્ટ છે જેને 70 અપ પર્સન્ટેજ છે, 60% સ્ટુડન્ટ છે જેને 70 નીચે પર્સન્ટેજ છે, 40% ને અપ છે, 60% ને 70 થી નીચે પર્સન્ટેજ છે. તો મારી પાસે આ ઓબ્ઝર્વેશન છે, એના બેઝ ઉપર હું એવું પ્રિડિક્ટ કરીશ કે ભાઈ સેમેસ્ટર 2 માં પણ 40% વિદ્યાર્થીઓ એવા છે જેને 70% ઉપર માર્ક આવશે, અને 60% વિદ્યાર્થી એવા છે અથવા તો સ્ટુડન્ટ એવા છે જેને 60% માર્ક આવશે. તો બરાબર, એ શું થઈ ગયું ભાઈ, તો કે મારી પાસે એક્ઝિસ્ટિંગ ડેટા છે, એની ઉપરથી મેં એમએસસી સેમેસ્ટર 2 ની પ્રિડિક્ટ કર્યું. તો એને શું કહેવાય છે ભાઈ, સો કે ઇટ ઇઝ નોન એઝ એ એમ્પિરિકલ હાઇપોથેસિસ. એને કહેવાય છે એમ્પિરિકલ હાઇપોથેસિસ. સો સ્ટુડન્ટ આ 10 ટાઈપની હાઇપોથેસિસ ધ્યાન રાખવાની છે. જ્યારે તમને એક્ઝામ, મે બી કોર્સ વર્કની એક્ઝામ આવે ત્યારે આવો ક્વેશ્ચન આવે, વોટ યુ મીન બાય ધ હાઇપોથેસિસ એન્ડ ડિસ્ક્રાઇબ ઓર રાઇટ ડાઉન ધ ડિફરન્ટ ટાઈપ ઓફ હાઇપોથેસિસ. તો આ 10 હાઇપોથેસિસ વિશે લખવાનું છે. પહેલી કઈ હતી ભાઈ, તો કે ઇટ ઇઝ અ નલ હાઇપોથેસિસ. બીજી હતી એ કઈ છે ભાઈ, તો કે વિચ ઇઝ અ અલ્ટરનેટિવ હાઇપોથેસિસ. થર્ડ કઈ હતી, તો કે સિમ્પલ હાઇપોથેસિસ. ફોર્થ, તો કે which is known as a complex hypothesis. Fifth, okay, which is a directional hypothesis. Sixth, which is a non-directional hypothesis. Number 7, which is a research hypothesis. Number 8, which is a statistical hypothesis. Number 9, which is a logical hypothesis. And number 10, which is whatever we are discussing about the empirical hypothesis. Based on the whatever observation or experiment, we design the hypothesis, which is known as an empirical hypothesis. So these 10 type of hypotheses are there when we're discussing about the statistics. Okay, so after the whatever we're discussing about the types of hypothesis, okay, we're discussing about the steps of hypothesis testing. Okay, whenever we design the hypothesis, then which kind of steps are followed by us, okay, to come towards the conclusion of that hypothesis. So when we're discussing about this, okay, steps into the hypothesis testing. So first, whatever our hypotheses are there, they are testing, which is a critical process in the statistics that allows the researcher to make the inference about the population based on the sample data. Okay, આપણે શું કરીએ છીએ, આપણે તો કોઈ લિમિટેડ જ કામ કરીએ છીએ, બરાબર. ફોર એક્ઝામ્પલ હું તમને એક્ઝામ્પલ આપ્યું કે ભાઈ મેડિસિનલ પ્લાન્ટ જે છે, which is responsible to cure the diabetes type 1 and type 2, XYZ કોઈ પણ મેડિસિનલ પ્લાન્ટ મેં લીધો, એવું એક મેં શું કર્યું છે ભાઈ અહીંયા, તો કે એક્સપેરિમેન્ટલ ડિઝાઇન કરી. ફોર એક્ઝામ્પલ એક્સ મેડિસિનલ પ્લાન્ટ લીધો મેં, એનું એક્સ્ટ્રેક્ટ બનાવ્યું, મેં એનું આલ્કોહોલિક મિથેનોલિક એક્સ્ટ્રેક્શન કર્યું એ મેડિસિનલ પ્લાન્ટના લીફનું, બરાબર. અને એ લીફના મેડિસિનલ પ્લાન્ટ જે છે એનું આલ્કોહોલિક મિથેનોલિક એક્સ્ટ્રેક્ટ બનાવ્યું. હવે એ એક્સ્ટ્રેક્ટને હું શું કરીશ ભાઈ, તો કે ડાયાબિટીક રેટ બનાવીશ. મારી પાસે રેટ હશે, નોર્મલ રેટ હશે, ડાયાબિટીક કંટ્રોલ રેટ હશે, અને બીજા બે ગ્રુપ બનાવીશું જેને ડાયાબિટીસ કરેલું છે રેટને, બરાબર. હવે જે મારી પાસે મિથેનોલિક એક્સ્ટ્રેક્ટ છે, બરાબર, એને હું એક્યુએસ એક્સ્ટ્રેક્ટ મિથેનોલને રિમૂવ કરીશ, જે સોલિડ મળશે એને એક્યુએસમાં હું ડિસોલ્વ કરીશ અને જે ડાયાબિટીસ ગ્રેડ છે બે મેં ગ્રુપ બનાવ્યા છે. એકને હું 150 મિલીગ્રામ પર બોડી વેટ એ મિથેનોલિક એક્સ્ટ્રેક્ટ જે છે આપીશ, પીવડાવીશ, અને બીજાને હું 300 મિલીગ્રામ આ મેડિસિનલ પ્લાન્ટનો જે એક્સ્ટ્રેક્ટ છે એ હું બીજાને આપીશ, બરાબર. પછી આફ્ટર સર્ટન ડેઝ ઓફ એક્સપેરિમેન્ટ હું મહિનો દિવસ એ એક્સપેરિમેન્ટ કરીશ, બરાબર. પછી હું એ રેટને ડિસેક્ટ કરીશ અને હું એમાં બ્લડ ગ્લુકોઝ લેવલ ચેક કરીશ કે ભાઈ હા બ્લડ ગ્લુકોઝ લેવલ કયા ડોઝમાં નોર્મલ થયું છે અથવા તો નથી થયું. તો એના બેઝ ઉપર હું શું નક્કી કરીશ ભાઈ, સપોઝ કે 300 મિલીગ્રામ પર બોડી વેટ મેં ડોઝ આપ્યો, એમાં મને ખબર પડી ભાઈ બ્લડ ગ્લુકોઝ લેવલ જે છે નોર્મલની નજીક આવી ગયું છે, બરાબર. તો જે અહીંયા જે છે ને, બરાબર, ઇન્ફ્લુઅન્સ અબાઉટ ધ પોપ્યુલેશન બેઝ ઓન ધ સેમ્પલ ડેટા. મારી પાસે તો એ સેમ્પલ ડેટા એક કોઈ પર્ટિક્યુલર રેટના ગ્રુપનો જ છે, બરાબર. તો એના બેઝ ઉપર હું શું પોપ્યુલેશનમાં સ્પ્રેડ કરીશ અથવા તો નક્કી કરીશ કે હા ભાઈ 300 મિલીગ્રામ ડોઝ પર્ટિક્યુલર એક્સ મેડિસિનલ પ્લાન્ટનો લીવ્સનો આપ્યો તો ભાઈ ડાયાબિટીસ જે છે આખા પોપ્યુલેશનમાં કંટ્રોલ થશે, બરાબર. આવું થાય છે. પણ હવે એ આખું પ્રૂવ કરવા માટે મારે શું કરવું પડશે ભાઈ, તો કે કેલ્ક્યુલેશન કરવી પડશે, ડેટા કલેક્ટ કરવું પડશે, આવું બધું મારે કરવું પડશે. તો શું છે આખી પ્રોસિજર, તો કે ધ પ્રોસિજર ઇન્વોલ્વ્સ several key steps to determine whether the observed data provides enough evidence to reject the null hypothesis in favor of the alternative hypothesis. Here, first we state that or we design the hypothesis. So first we design the null hypothesis. We already know about that. Okay, this is a default assumption that there is no effect or relation between the variables. It serves as the baseline of the hypothesis. For example, હું null hypothesis જે આપણે રેટ વાળું એક્ઝામ્પલ લઈએ છીએ એમાં હું શું ડિસાઇડ કરીશ અથવા તો શું કરીશ ડિફાઇન કે ભાઈ જે પણ ટ્રીટમેન્ટ આપી છે મેડિસિનલ પ્લાન્ટની એ ડાયાબિટીસને કંટ્રોલ કરતી નથી. સો વિચ ઇઝ માય નલ હાઇપોથેસિસ. ઓકે, એ મારી શું હશે ભાઈ, તો કે વિચ ઇઝ માય નલ હાઇપોથેસિસ. વોટ ઇઝ ધ અલ્ટરનેટિવ હાઇપોથેસિસ, તો એવું કે જે ભાઈ એ કંટ્રોલ કરે છે એવી મારી અલ્ટરનેટિવ હાઇપોથેસિસ હશે. ઓકે, સો આ અલ્ટરનેટિવ હાઇપોથેસિસ કે ધીસ ઇઝ અ હાઇપોથેસિસ that there is an effect or relationship between the variables. The goal of hypothesis testing is to determine whether there is enough evidence to reject the null hypothesis in favor of the alternative. Okay, મારી પાસે enough evidence છે કે હું રિજેક્ટ કરી શકું null hypothesis. તો મારી પાસે એવિડન્સના ફોર્મમાં શું હોય? ઓકે, when we discussing about the diabetes, so પેલું શું હશે આપણા માઇન્ડમાં, તો કે ગ્લુકોઝ લેવલ કેટલો આવે છે, બરાબર. જ્યારે પણ ડાયાબિટીસની વાત કરીએ તો પેલું શું આવે ભાઈ માઇન્ડમાં, તો કે વોટ ઇઝ અ ગ્લુકોઝ લેવલ. ઓકે, તો પેલું વેરિયેબલ મારી પાસે શું હશે ભાઈ, તો કે ગ્લુકોઝ લેવલ શું છે બ્લડનું, બરાબર. પછી હું ડિફરન્ટ એન્ઝાઇમને ચેક કરીશ. Okay, second શું છે ભાઈ, તો કે what are the different enzymes, okay, which is also one of the variable. So based on that data collection, okay, that entire analysis, we conclude about the our null hypothesis which is accepted or not, or alternative hypothesis which is accepted or not. So this is about step number 1, state the hypothesis. Okay, here you see the flow chart. Okay, first what we do, state the null hypothesis as well as alternative hypothesis. Then second, specify the level of significance and select the appropriate test. Number third, collect the and summarize the data. Then collect the test statistic. Then determine the p value or critical value. After that, we make a decision on the basis of compiling whatever the data which is there, okay, or on the basis of comparing the p value or the level of significance, okay, which is known as alpha, or compare the test statistic for the critical value. So based on that we reject or accept the null hypothesis. Okay, based on that we reject or the accept the null hypothesis. If we reject, okay, thereby we run the risk of committing the type 1 error, or when we accept the null hypothesis, at that time may it happen that okay, we committed the type 2 error also. So one by one, okay, after the state the hypothesis, one by one we discussing. Number two, which is a choose the significant level, which is a alpha. Maybe you see into the research paper, okay, that the p value which is there, okay, p less than 0.05. In some of the research paper you see that okay, p which is a less than 0.05. In some of the research paper may you see that okay, the p value which is a less than 0.01, or maybe in some of the research paper you see that okay, the p value, okay, which is a less than 0.10. So here this is a significant level, okay, which is decided by us, which is known as a alpha. So alpha, you remember that, okay, which is a significant level, typically denoted as a alpha. This is a probability of rejection of the null hypothesis when it is actually true, and we committed the type 1 error. So once again, students, you remember that it is a probability or P, okay, it is a probability or P of the rejecting the null hypothesis when it is actually true and we committed the type 1 error. So common alpha value, okay, whenever you do the research work, so common, okay, error or the alpha which is selected in the most of the research paper you see that okay, which is a 0.05, or we can say it is a level of 5%. Number second much selection of appropriate test, which is also play an important role. So based on our experimental design, our data collection, okay, we design the different test or appropriate test. For example, whatever the distribution of data which is there, research questions are there. Based on that, different test which is available. Here, mostly students go for the student t test. Okay, maybe the data which is a less than 3030 or more than 3030, then we can go for the z test. If the any okay qualitative data are there, then we go for the chi-square test. And if the variables are complex variable, okay, more than two variables when we compare, then students go for the analysis of variance, which is known as shortly ANOVA. Next, the whatever we choose the test, which is depends on the factors such as whether the data which is a categorical or continuous, and whether you are comparing the means, proportion, or other statistics. So students, once again I tell you, okay, it's depend on two. Okay, whatever the types of data which is there, data distribution which is there, as well as whatever the research question on that. Okay, it's depend for the selection of the test. Maybe you select the t-test, maybe you go for the ANOVA. If you have the data regarding the quality, for example, કોઈ સ્ટુડન્ટ્સ જે છે એ મેન્ડેલિયન લો ઉપર કામ કરે છે, બરાબર, એને ક્રોસ બ્રીડ કર્યા. સપોઝ કે એક પ્લાન્ટ જે છે એ વ્હાઇટ ફ્લાવર આપે છે, બીજું છે એ રેડ ફ્લાવર આપે છે, અને ઇન ધ જનરેશન ઓફ ઓકે ફર્સ્ટ જનરેશન F1 જનરેશનની વાત કરીએ, ક્રોસ બ્રીડ થાય એટલે કેવા મળશે ભાઈ? તો કે મે ઇટ હેપન ધેટ કે ત્રણ પ્લાન્ટ જે છે એ રેડ ડોમિનન્ટ હોય તો રેડ ના મળે, અને એક જે છે એ કેનો મળશે ભાઈ? તો કે વ્હાઇટ નો મળશે. તો 3:1 રેશિયો મળવો જોઈએ. તો આવું જ્યારે ક્વોલિટીની વાત કરીએ, બરાબર, કલરની વાત કરીએ, તો સ્ટુડન્ટ્સ જે પણ ડેટા મળે એ કેના રીતના ટ્રીટ કરશે? તો કે વિથ ધ હેલ્પ ઓફ chi-square ટેસ્ટ કરી અને એનું આખું એનાલિસિસ કરશે. and based on that they define the hypothesis as well as alternative hypothesis. તો આવું જ્યારે કરે ત્યારે જ્યારે ક્વોલિટેટિવ ડેટા બરાબર હશે ત્યારે ક્વોન્ટિટેટિવ હોય ક્વોન્ટિટી મેઝર થતી હોય એવા ડેટા હોય ત્યારે maybe students they are go for the t test self test or they are going for the ANOVA test also. So this is our number 2. Okay, choose the significant level which is alpha. Probably you see in the research paper alpha which is a 0.05 level of significance which is state as a P. When we're discussing about the second mark appropriate test design અથવા તો સિલેક્ટ કરવાની હોય છે ઇમ્પોર્ટન્ટ શું છે કે it is specifically based on the type of data and the data distribution pattern. Number third, okay, which is a collection as well as summarizing the data. So whatever the data collection which is there in the form of what you collect the data, okay, in the form of mean value you collect the data, in the form of standard deviation you collect the data, in the form of standard error you collect the data. So likewise, okay, how you summarize your data, okay, so which is one of the important things when you're discussing about the testing the hypothesis. So here gathering the sample data through the experiment, observation or the survey, then summarize the data with the help of the descriptive statistics which is a mean, standard deviation and whatever we prepare that specific analysis. So this is a number 3 which is a collection as well as the summarizing the data. Number 4 which is a calculation of the test statistics. 1 minute, students. So whatever the application of the formula onto that data, they play a very important role, which is come into the calculation of the test statistics. So here use the selected statistical test to calculate the test statistic which measure the degree to which the sample data is constructed with the null hypothesis. The formula for the test statistic which is a vary depend on to the types of test which is used. So once again whatever the we discussing about the calculation of the test statistic, in that the different formulas are used to analyze our data further. So it come into the calculation of test statistics. Number 5, determine the p value or the critical value. So p which is a probability value, calculate the p value which represent the probability of the obtaining the test statistics at least of the extreme as the one observed, accepting that the null hypothesis which is true. Number 5 in that another which is a critical value. So critical value which is an alternative value, you can determine the critical value corresponding to the choose the significant level. The critical value define the cutoff point beyond the beyond which the null hypothesis will be rejected. So mainly when you going for the or we discussing about the different sum, okay, in that the critical value which is already given, okay, which is a specifically tabulated value. Whatever the p values are there, which is a calculated value for us, okay, based on the calculation of test statistics, we get the certain value. And when we're discussing about the critical value, which is a tabulated, okay, if you have the any statistical book or the biostatistical book, so on the back the tables are given, which is a t table or which is a chi-square tables are there. In that the critical values are there. So which is a critical value. When we're discussing about the number 6 and which is a very important, make a decision, okay, based on whatever our critical values are there, we calculate the p value. Based on that now our responsibility is that we make a certain decision. Okay, so compare the p-value to the significant value alpha. If the p-value is less or equal to alpha, then we reject the null hypothesis H0 and we accept the alternative hypothesis which is a H1. So the suggestion is there the enough evidence with us to support the alternative hypothesis. When if we have the p-value which is a less than or equivalent to alpha value. Okay, if we decide the alpha value which is a p less than 0.05, so whatever we get the p value, okay, if it is less than or equivalent to that, then we reject the null hypothesis and we accept the alternative hypothesis. If the p value which is a greater than alpha, then do not reject the null hypothesis. This suggests that there is no enough evidence to support the alternative hypothesis. So we ultimately accept the null hypothesis. Okay. Alternatively, we compare the test statistic to the critical value. If the test statistic fall into the rejection region beyond the critical value, okay, then whatever these okay hypotheses are there, null hypotheses are there, we reject. If the test statistic does not fall in the rejection region, do not reject the null hypothesis. Okay, later on we discussing about this. Okay, okay, what is the rejection region which is there, what is the critical region which is there, with the help of graph. Okay, we discussing about this which is a critical region as well as the rejection region. Based on the diagram, we discussing this. Okay. After that, we are come to the draw the conclusion. Okay. Based on the decision, draw the conclusion about the research question. If the null hypothesis is rejected, conclude that there is evidence to support the alternative hypothesis. If the null hypothesis is not rejected, then conclude that there is no enough evidence to support the alternative hypothesis. So this is about the drawn the conclusion. Okay. For example, whatever we give the example of medicinal plant treatment to the diabetic rat, if enough evidence are there, okay, with us, okay, the medicinal plant sufficiently able to reduce the blood glucose level. So based on that, we draw the conclusion that okay, on a certain dose, for example, 300 milligram per body weight, a medicinal plant X, which is responsible to control the diabetes into the rat. Okay. So likewise, we draw the specific conclusion based on our findings. So this is known as a conclusion. After that, a report as well as results. So clear reports of that finding will be done by students you, including the test statistics, which kind of test statistic you perform, include the p-value, whether the null hypothesis which is rejected or not. You also mention in that your report as well as your results provide the context of the result, explaining things. You also write what they mean in terms of original research questions. So likewise, whenever you do the research, you write down the thesis, you write down the research paper, or maybe you refer the many research paper. Okay, in that the tables which is given. Okay, in that the bottom of table. Okay, all these details are given, or in the methodology also, whatever researchers are there, they mention. Okay, which test statistics they do, on the what probability value they are going to perform the null hypothesis, if the null hypothesis is rejected or not, or they provide all the detailed things in the research paper or maybe the report. So likewise, you do the reporting, students, whenever you finalize your conclusion. After that, okay, by following these steps, researcher can be okay systematically evaluate their hypothesis and draw valid conclusion based on the data. contributing to the body of knowledge in their specific field. So likewise, entire process which is done when you're discussing about the testing of hypothesis. Testing of hypothesis, these 8 different steps, they play an important role. Now, actually we do the testing of the experimental hypothesis. So how we do this? Okay. So first, testing an experimental hypothesis involve applying the statistical method to determine whether observed results are due to chance or reflect a real effect. So in that, the following concepts are fundamental into the testing of hypothesis. First, we are able to analyze or find out the standard error. In that, number one, what do we mean by that? Okay, standard error means what? Okay, it is a statistical measure that indicate the precision of the sample estimate, such as the mean. Okay, what we do, the whatever we collect the blood analysis sample of the rat. Okay, in one experiment, if we have the 6 different rats are there, so what we do, we take the mean. After that, whatever the mean readings are there, we are applying or we calculate the standard error. Why? So it gives the precision of the sample estimated. Whatever we analyze the sample, it gives the precision. For example, whenever you do the research or you find out the research paper, in that some values are given, and after that it is written plus or minus some another values are there. So what are the plus or minus values are there? They indicate the precision of the whatever you do the estimation. It reflects the variability of the statistic for the sample to sample, because whatever the 6 samples are there, okay, and you get the mean. તો દરેકનું સેમ્પલનું વેલ્યુ સપોઝ કે ડાયાબિટીસ ઉપર કામ કરી છે તો નોર્મલ વેલ્યુ 120 મિલીગ્રામ પર ડીએલ આવું એવું હોતું નથી. પર્સન ટુ પર્સન, ઓકે, સેમ્પલ ટુ સેમ્પલ ટ્રીટમેન્ટ આપવા પછી એની વેલ્યુમાં કઈ ચેન્જ આવ્યો હશે, બરાબર? તો દરેક પર્સનની વેલ્યુ જે સપોઝ કે કોઈની 120 મિલીગ્રામ પર ડીએલ ગ્લુકોઝ વેલ્યુ હશે, કોઈની 122 હશે, કોઈની 125 હશે, કોઈની 115 હશે. તો લાઇકવાઇઝ વેરિએશન વિચ ઇઝ ધ સેમ્પલ ટુ સેમ્પલ, પણ એ વેરિએશનને કઈ રીતના આપણે પ્રિસાઇઝ કરી શકીએ, બરાબર? તો એ કઈ રીતના કરી શકીએ? વિથ ધ હેલ્પ ઓફ સ્ટાન્ડર્ડ એરર એસ્ટિમેશન. સો કઈ રીતના કરવાનું છે? તો ફોર્મ્યુલા વિચ ઇઝ ગિવન here. So first we analyze the standard deviation and the n, which is whatever the sample size which is there. Formula is standard error. અહીંયા લગભગ નથી લખાણી, પણ એવું છે, standard error is equal to standard deviation divided by root of n, means sample size. Next we discussing about where we use this standard error. What is the significance to calculate the standard error? So significance, a smaller standard error, it indicate more reliable as well as the precision into the estimation. Standard error which is used into the confidential interval and the test statistics like Z test as well as T test. We analyze the standard error and then we put into the test statistic formula. પણ કઈ રીતના મળે છે સ્ટાન્ડર્ડ એરર? તો કે પહેલા આપણે શું શોધવું પડશે ભાઈ? સ્ટાન્ડર્ડ ડેવિએશન શોધવું પડશે. સ્ટાન્ડર્ડ ડેવિએશન ડિવાઇડેડ બાય રૂટ n અથવા તો સેમ્પલ સાઇઝ. સો એ ઉપરથી આપણે શું મળશે ભાઈ? વી કેન ગેટ ધ સ્ટાન્ડર્ડ એરર. આફ્ટર ધેટ ફર્સ્ટ કઈ જોઈએ આપણે? સ્ટાન્ડર્ડ એરર કેલ્ક્યુલેશન. Then we go for the test of significance. તો ટેસ્ટ ઓફ સિગ્નિફિકન્સમાં ઘણી બધી ટેસ્ટ આવે છે, બરાબર? ફર્સ્ટ વી ડિસ્કસિંગ અબાઉટ વોટ યુ મીન બાય ટેસ્ટ ઓફ સિગ્નિફિકન્સ. So the test of significance determines whether the observed differences or relationship in a sample is statistically significant or not. Okay. ઘણી બધી ટેસ્ટ આવે છે. તો કોમન ટેસ્ટ ફોર ધ સિગ્નિફિકન્સ આર ટી શેના માટે વપરાય છે? તો કે which is useful for the small sample size. Z શેના માટે વપરાય છે તો કે which is useful for the large sample size with us. Chi-square તો કે which is a categorical data which is there. I already told you about that. If the qualitative data are there, category wise data with us, then we are going for the chi-square analysis. F test અથવા તો ANOVA એ શેના માટે વપરાય છે તો કે comparison of more than two variables or two means, then we are going for the F test or the ANOVA test. So procedure already we know, or already we discussing about that. So first we state the null hypothesis as well as we design the alternative hypothesis. Then we choose the appropriate test statistics. After that we fix the level of significance, which is a P level for us, okay, or which is a alpha level. Mostly alpha level which is a 0.05. Then we discussing about the calculation of test statistics. After that, whatever the comparison, okay, with the critical value or p value, then based on that, if it is an increase or we find out the decrease, then based on that we accept or reject the null hypothesis. So number 2, which is a test of significance. Based on our sample or the data collection, okay, we are going to perform the different tests like t test, z test, chi-square, F test, or the ANOVA test. Okay. Number 3, which is a very important, which is a level of significance. At which level we are going to test our hypothesis. So the level of significance, which is a probability of rejecting the null hypothesis when it is actually true. Okay, we reject the null hypothesis when it is actually true. The common level for the alpha, which is a 0.05, which is a 5%, most commonly used. 0.01, which is 1%, which is a highly, okay. Whenever we are going to perform any precision, okay, then we are going to 1% level of significance. કોઈ મેડિકલ ટેસ્ટની વાત કરીએ, બરાબર, જે ડાયરેક્ટલી અફેક્ટ કરે છે હ્યુમનને, તો ત્યારે જે પ્રિસિઝન હોય ડેટામાં એ કેવું હશે ભાઈ 1%, અથવા તો એ હજી વધારે હશે, બરાબર, 0.01% પણ હશે. ક્યારે? જ્યારે કોઈ મેડિકલ ફિલ્ડની વાત કરીએ છીએ, જે ડ્રગ ડિસ્કવરીની વાત થાય, ડ્રગના એક્સપેરિમેન્ટની વાત થાય, તો ત્યારે શું વાત થાય ભાઈ ખરેખર, તો કે એ બહુ પ્રિસાઇઝ, કેમ કે ડાયરેક્ટલી હ્યુમન લાઈફ સાથે, બરાબર, એનો કોન્ટેક્ટ છે, તો ત્યારે જ્યારે લેવલ ઓફ સિગ્નિફિકન્સ એક્સપેરિમેન્ટનું કેટલું રાખવું પડે, સો કે ઇટ ઇઝ અ 0.01. ઓકે, પ્રિસાઇઝલી આપણે બધા રિસર્ચ કરીએ છીએ, બરાબર, નોર્મલ રિસર્ચ, ક્રૂડ રિસર્ચની વાત કરીએ ત્યારે આલ્ફા લેવલ કેટલું હોય છે, તો કે ઇટ ઇઝ અ 0.05. નોર્મલી જ્યારે કોઈ મેડિકલના પેપર તમે જોશો ત્યારે આલ્ફા લેવલ અથવા તો પી લેસ ધેન 0.01 એવું હશે. અને નોર્મલ રિસર્ચ પેપર એન્ઝાઇમ એક્ટિવિટી અથવા તો એવા સર્ટન પેપર જોશો તમે ત્યારે લેવલ કેટલું હશે પી, તો કે વિચ ઇઝ અ લેસ ધેન 0.05 એવું હશે. ઇન્ટરપ્રિટેશન કઈ રીતના થાય છે, તો કે ઇફ પી, બરાબર, લેસ ધેન ઓર ઇક્વલ ટુ આલ્ફા, then we reject the null hypothesis. If p, which is greater than alpha, then fall to rejection of the H0. ઓકે, એ આપણે ડિટેલમાં જ્યારે ગ્રાફિકલ રિપ્રેઝન્ટેશન સાથે સમજશું ત્યારે રિજેક્શન રિજિયન શું છે, એક્સેપ્ટન્સ રિજિયન શું છે, based on that we discussing about that interpretation part. After that, number 4, which is a degree of freedom. Meaning of that degree of freedom represent the numbers of independent observations that are free to vary while estimating the statistical parameters. So here DF, degree of freedom, specifically in the sample mean, which is n-1 લઈએ છીએ. For example, we have the number of sample which is 20, then degree of freedom which is 20 minus 1, which is 19. Likewise, we take the degree of freedom. When we're discussing about the chi-square test, so in that the degree of freedom we take as a r minus 1, as well as C minus 1 means whatever our information with us in the form of row, which is a R, and whatever the information with us in the form of column, which is a C. So this is a degree of freedom for us. તેને શું કહીએ છીએ આપણે ભાઈ? તો કે DF. What is the important? તો કે determine the critical value of test statistics and depends on the sample size as well as the test time. Okay, we are discussing about the degree of freedom. Okay, then error into the hypothesis testing, which is known as a type 1 error, which is an alpha error. So occur when the null hypothesis is rejected even it is true, also called as a false positive. Possibility of type 1 error, which is known as the alpha, or it is level of significance. The example are concluding the drug is effective when it is actually not. So this is known as a type 1 error. Okay. So here null hypothesis which is rejected even if it is true, then it is known as a false positive or type 1 error. Type 2 error, which is known as a beta error, occur when the null hypothesis which is not rejected when there is false. Actually, it is known as a false negative. Probability, the type 2 error, which is known as a beta, concluding the drug is ineffective when it is actually the effective, which is known as a type 2 error. Power of test, it represents the ability of the test to determine the true effect. So specifically when we're discussing about the type 1 and type 2 error, they play an important role whenever we're discussing about the testing of hypothesis. સમજવા જેવું છે, type 1 error ને alpha error કહેવાય છે, type 2 error ને beta error કહેવાય છે. Clear? So here false negative છે. Type 2 error કેવી છે ભાઈ? False negative. Concluding શું કરીએ છીએ? Drug is ineffective when actually it is effective. તો એવું જ્યારે બને, બરાબર, તો એને શું કહીએ છીએ આપણે? બીટા એરર કહીએ છીએ અથવા તો type 2 error એવું કહીએ છીએ. જ્યારે type 1 error કેવી છે ભાઈ? તો કે null hypothesis is rejected even though it is true. ખરેખર null hypothesis true છે, પણ તેમ છતાં પણ આપણે શું કરીએ છીએ ભાઈ? એને રિજેક્ટ કરી નાખીએ. તો એ કેવું છે ભાઈ? false positive. તો કન્ક્લુડિંગ શું કરીએ છીએ કે drug is effective when it is actually not. So this is known as a type 1 as well as type 2 error. Okay. Risk of rejecting the null hypothesis when it is true. બરાબર, એ વાત કરીએ છીએ તો અહીંયા શું છે? સુપર ક્રિટિકલ, બરાબર, આ એરિયા ડિફાઇન કરેલા છે. ક્રિટિકલ, સુપર ક્રિટિકલ, ઇમ્પોર્ટન્સ અને મોડરેટ શું છે? તો મેં હમણાં જ વાત કરી, જ્યારે મેડિકલ ફિલ્ડની વાત આવે, બરાબર, ત્યારે આપણે શું પ્રિસિઝન લઈએ છીએ ભાઈ? તો કે રિસ્ક ફેક્ટર કેવું રાખવું જોઈએ ભાઈ? અથવા તો આલ્ફા લેવલ ટાઈપ 2 નું લેવલ કેટલું રાખવું જોઈએ? તો કે ઇટ ઇઝ અ 0.001 અથવા તો ખાલી 0.1% જ હોવું જોઈએ. કોન્ફિડન્શિયલ ઇન્ટરવલ ત્યારે કેવો હોય છે ભાઈ? તો કે 99.9% જે છે એ સાચું હોય એને શું કહે છે? કોન્ફિડન્સ ઇન્ટરવલ. તો ડિસ્ક્રિપ્શન ક્યારે આવવું જોઈએ? કે મોર દેન 100 બિલિયન, તો લાર્જ લોસ ઓફ ધ લાઈફ બને, બરાબર. ફોર એક્ઝામ્પલ ન્યુક્લિયર ડિઝાસ્ટર, આવું કંઈ કરતા હોય. મેં તમને કીધું કે મેડિકલ ડ્રગને જ્યારે માર્કેટમાં મૂકવાની થાય તો એનાથી શું થઈ શકે છે? જો આપણે ફોલ્સ, બરાબર, ડિસિઝન આવે તો લાર્જ લોસ ઓફ ધ પીપલ્સ આર ધેર. તો એટલા માટે, બરાબર, શું કહીએ છીએ ભાઈ? તો કે 0.1 સુપર ક્રિટિકલ રાખીએ છીએ. મીન્સ આટલો પણ ચાન્સ હોય તો પણ આપણે શું કરી દઈએ છીએ? એને નલ હાઇપોથેસિસને રિજેક્ટ કરી દઈએ છીએ. શું કરી દઈએ છીએ? તો અહીંયા શું કરી દઈએ છીએ? તો કે રિજેક્ટ ઇવન ઇટ ઇઝ ટ્રુ. બરાબર, શું કરીએ છીએ? નલ હાઇપોથેસિસ ઇટ ઇઝ અ રિજેક્ટ ઇવન ઇટ ઇઝ ટ્રુ. બરાબર, આટલા પણ ચાન્સીસ લાગે તેમ છતાં પણ આપણે શું કરી દઈએ છીએ? સુપર ક્રિટિકલ કેસમાં શું કરી દઈએ છીએ? આપણે એને રિજેક્ટ કરી દઈએ છીએ. ઓકે, કેમ? because it is involved the matter of many lives. Critical હોય કોઈ વસ્તુ તો કે 1% level which is known as a 0.01%. ત્યારે કોન્ફિડન્સ ઇન્ટરવલ કેટલો હોય છે તો કે 99%, તો કે લેસ ધેન ઓકે 100 millions or the few lives which is lost. ઇમ્પોર્ટન્ટ શું છે ભાઈ, તો કે આપણે જે બધા કામ કરીએ છીએ એ કેવા કેટેગરીમાં આવશે ભાઈ, તો કે ઇમ્પોર્ટન્ટ કેટેગરીમાં 5% લેવલ. તો કે ઇન ધેટ ધ આલ્ફા લેવલ which is a 0.05, our confidence interval which is a 95% and less than thousands, okay, 10,000 or 100,000 or no live loss which is there or injury which is occur, ત્યારે આપણે કોન્ફિડન્સ ઇન્ટરવલ કેટલો રાખીએ છીએ ભાઈ, તો કે 95%, અથવા તો રિસ્ક ફેક્ટર કેટલું છે તો કે 5%, મોડરેટ હોય તો 10%, 90% કોન્ફિડન્સ ઇન્ટરવલ and that the no injury which is occur. So likewise we design the null hypothesis, અથવા તો type 1 and type 2 errors are there. So here now you maybe get a better idea about that. The null hypothesis which is there, we accept the null hypothesis which is correct, but when we reject the null hypothesis at a particular level, then we occurring the type 1 error. Null hypothesis which is false we accept, તો false હશે ને તો પણ accept કરી લઈએ તો એ બહુ danger error કહેવાય, which is known as a type 2 error, which is the most danger error. And if we reject, then it is our decision which is correct. Okay, so likewise the type 1 and type 2 error, they play an important role into the testing of the null hypothesis. Okay, તો ગ્રાફિકલ જ્યારે વાત કરવાની મેં કીધી તમને બરાબર, તો વોટ એવર વી ગેટ ધ ડેટા એનું જ્યારે સમરાઇઝ કરીએ અથવા તો સિમ્યુલેશન કરવામાં આવે તો ડોમ શેપ મળે છે બરાબર. આ જે ડેટાનો ગ્રાફ મળે છે એ કેવો મળે છે આપણે, તો કે આવો ડોમ શેપ બેલ શેપ સ્ટ્રક્ચર મળે ગ્રાફનું. તો જે એક્સેપ્ટન્સ રિજિયન છે બરાબર, જે મીન વેલ્યુની વાત કરીએ છીએ એ એક્સેપ્ટન્સ રિજિયનમાં અહીંયા ફોલ થાય. કેટલા ફોલ થાય, સપોઝ કે મેં 100 રીડિંગ લીધા, એમાં 95% જે અહીંયા ફોલ થાય છે બરાબર, કોઈ 5% રિઝલ્ટ જે છે એ અમુક જે છે એ લેફ્ટ પોઝિટિવ ફોલ થાય ઓર મે બી અમુક જે છે નેગેટિવ ફોલ થાય, તો એ આ રિજિયનમાં ફોલ થાય. એને શું કહેવાય છે ભાઈ, રિજેક્શન રિજિયન કહેવાય છે, અથવા તો એને સિગ્નિફિકન્ટ લેવલ આલ્ફાની વાત કરીએ છીએ. તો આવું બને છે. સો જ્યારે આપણે નેક્સ્ટ ટાઈમ પાછા મળશું સ્ટુડન્ટ્સ બરાબર, ત્યારે પાછું આ ગ્રાફ વિશે સમજશું, એઝ વેલ એઝ we are discussing about what is the acceptance region as well as what is the rejection region. In detail we discussing about this as well as this graph which is a one tail graph, and this is also the known as a right tail or left tail graph. તો એને શું કહેવાય, આ રિજિયન કયું છે કોન્ફિડન્શિયલ લેવલ બરાબર, એ બધું જે છે એ જ્યારે પાછા મળશું આપણે ત્યારે સમજશું. પછી આ આખો ફ્લો ચાર્ટ શું હોય છે એ બધું ત્યારે સમજશો. તો આજના દિવસ પૂરતું, આજના લેક્ચર પૂરતું વી સ્ટોપ હિયર ટુ ધ ટાઈપ 1 એઝ વેલ એઝ ટાઈપ 2 એરર એન્ડ ડિટેલિંગ શું હોય છે બરાબર, કઈ રીતના કામ કરે છે અથવા તો કોને કહેવાય છે, વોટ વી મીન બાય રિજેક્શન રિજિયન, એક્સેપ્ટન્સ રિજિયન, what is this dome shape graph after we collection of the data. We know this is a hypothesis of us, okay, null hypothesis h is to mu is equal to mu 0. So whatever these things are there, we discussing into the next lecture. If you have any doubt, query, okay, then you easily contact with me with the help of my email id. My email id which is sgchotia chauvati@sauni.ac.in. You raise your query if you have any queries. Thank you, students. Sir, we can stop here. Okay. Okay, thank you, sir.